Okay, now we're going to use the LES model that we discussed in the previous small example. Okay, we're going to apply that into a real practical model where the WJF sales data, where we have data for 62 weeks. And again, we're going to divide the data into two parts. The part where we do the modeling, which is weeks 1 through 26, and then we'll look at that model, apply it to the holdout sample, which is 27 through 62. So we'll use point 1 and point 3 as the initial value for alpha and beta. We'll use point 3 and point 1 as the initial values for alpha and beta. Okay. And the initial value for trend is y sub 3 minus y sub 1 divided by 2, and initial value for level is the average value of these three plus the trend. Okay, so now we add that, and that will give us the forecast for the next period, and the error will be actual value minus the forecast. Okay. Now the smoothing will be the forecast plus alpha, make that absolute reference, times the error. So that's our smoothed level value, and for trend it will be previous trend plus beta, make that absolute reference, times L minus F. That's the trend. Now we can copy that rest of the way. Okay, put the border back. Okay, so now we're going to compute our error measures starting from week 6. Now let's compute the error measures starting with RMSE. Okay, we're going to use week 6 through 26 actual values, come out the forecast. Okay, and use a similar format to find MAE and MAPE. There's MAE, here is MAPE. So now let's use MASE. Okay, so now we have to provide the random walk forecast for weeks 6 through 26. That will be actual values from weeks 5 through 25. Okay. And a similar fashion we set up deals U. Okay, so now that we have this set up, we can now run solver. So go to solver. We'll first use RMSE. We want to minimize that by changing values of alpha and beta. Okay. And now we want both alpha and beta to be less than or equal to 1. Click OK, and since we are checking this, alpha and beta will be greater than 0. So it will be between 0 and 1. And we select GRG nonlinear. We solve. And we have found a solution. Okay, so this is the alpha we get and the beta. Okay, and And these are the best values based on RMSE. Okay. Now if we continue this, okay, let's bring the level and trend, okay, from the previous analysis sample, and then that plus that is the forecast for week 27, and we can copy the one of the error formulas down here, so that will give you the error. Okay, and we can select any row from here for the formulas for level and trend. Then we copy that. So now we can copy this entire row all the way down, so that will give us the forecast for the holdout sample based on the model we developed with estimation rows 1 through 26. So now we're going to set up our error measures, okay, for both the estimation rows and for the holdout rows. Try to compare the accuracy measures for the estimation rows 1 through 26 and the same measures for the holdout sample 27 to 62. And let's see what alpha and beta values we want to experiment or we want to set these tables for. We already ran solver for minimizing RMSE, and when we solved it, okay, we got an alpha value of 0.694 and 0. So let's copy that alpha value down here, and 0 for beta. Okay, we need to keep that in mind. Let's see whether different betas are necessary. Now if you use MAE as the objective to minimize, we solve. Okay, now let's see what we get. We get same 0 but slightly different alpha value. So let's see, we have two different alphas. Let's see what happens if we try to minimize MASE. So we try to minimize F35. So that gives you again beta equal to 0, and it gives you same value. So this is minimizing what? The first one is RMSE, the second one is MAE, the third one is MASE. So these are the three different criteria that we are minimizing, and these are the different alpha values we end up with, and we want to tabulate RMSE, and we can copy a couple of them there. Okay, from these three, and then MASE and MAPE. Okay, now we can run a data table. Now remember, alpha is in a row, so we have to go data table, row input cell. Okay, beta is going to do the same, 0. Alpha is the only one that we're going to change. And here are the values that we get. This is for the estimation rows 1 through 26. Let's call MAPE into a percentage, and we'll hide this by whiting out. Okay. Now we want the same thing, same alpha values as before. Okay, RMSE, MAE, and MASE alpha values, but this time we want the error measures for the holdout samples. So let's set that up now. So first RMSE weeks 27 through 62 on the forecast. That gives us RMSE. Next is MAE, mean absolute error. Then MAPE. Then MASE. So now we have the original data, weeks 27 to 62, the forecast we are considering, and then we need the random walk forecast. So that will be the original values from week 26 to 61. So that's here 26 to 61. So that gives us the MASE value, and same for Thiel's U. So these are the values for the holdout sample. Now let's run data table here with alpha being the row input cell going to B4. Okay, so now let's format these. MAP is percentage. Okay, and let's hide this by whiting out. So there we can now compare that the estimation error measures are slightly better than the random walk, but if you look at the holdout rows, you see the best LES model is still not as good as just the random walk model. So even LES model is not, the best LES model is not giving you a better forecast for the WFJ sales data.